Here we have the limit as x approaches 2 of x squared minus 4 over x minus 2. So of course I'm going to find my limit using direct substitution. That's always my plan A. So I have 2 squared over 2 minus 2, which gives me 4 minus 4, which is 0 over 2 minus 2, which is 0. Oh my goodness. This is what we call an indeterminate form. It means our plan A, which is always direct substitution, failed. It failed to give us a trend in Y. So, folks, we better have a plan B. And we do. If plan A doesn't work, we're going to try to do the following. Factor, cancel, and then try direct substitution. Let's see, the limit as x approaches 2. Well, let's factor. Well, in the numerator, we have a difference of perfect squares. X minus 2, x plus 2. Thank goodness I took pre-algebra, algebra 1, algebra 2, and pre-calculus. So I know how to factor that immediately. And look, because we have multiplication here, we can cancel. So the surviving function is x plus 2. And now I can use direct substitution to get 2 plus 2 is 4. So I was able to find the limit. Now, look at the surviving function here after we canceled. It's x plus 2. And that means we have a slope of 1 over 1 and a y-intercept of 2. And we're saying as x approaches 2, y is approaching 4. But this function has no holes. Of course it has no holes. It's just a line. The parent function, x squared minus 4 over x minus 2, and the surviving function, all right, SF, not San Francisco, but surviving function, have the same graph, except the original function is going to have a hole. Where? Well, as soon as you see this 0 over 0, you know you're going to have a hole. Where? At x is approaching 2. Well, as x approaches 2, y is going to 4. We say the limit is not reached. We have a hole at 2, 4. How do I know? It's telling me x is approaching 2. And don't forget, this is the trend in y. So that means as x approaches 2, y is approaching 4. And this is what our graph looks like. Here, I find the limit on the y-axis. Let's find the limit as x approaches 0 of x minus x squared over x. Clearly, when I try my plan A, direct substitution, I get 0 over 0, which is an indeterminate form. So I know already, graphically, I'm going to have a hole there. So again, my plan B, if plan A, direct substitution, doesn't work, I better have a plan B. And plan B is going to be factor, cancel, and then on the surviving function, I'm going to use direct substitution. Let's see, limit x approaches 0 of what's common to x squared and minus x, that's going to be x. I'm left with x minus 1 over x. Let's see, x times x is x squared, x times minus 1 is negative x. I always check before I move on. Because I have multiplication here, I can cancel, and I'm left with the limit as x approaches 0 of x minus 1. I call this the surviving function. Now I can use direct substitution and get negative 1. There is my limit. Now, what does this graph look like? Here is our surviving function, x minus 1. That means slope of 1 over 1, y-intercept of negative 1. It looks something like this. And we're saying, here is x0. This is the x-axis. We're squeezing in both directions. We're saying, where is y going to? It's right there. Well, of course, our surviving function has no holes. The original graph looks the same, except there's a hole. Where? Well, as x was heading to 0, y is trending towards -1. So this, in fact, is a hole here. I knew immediately when I saw this 0 over 0, it was telling me, hey, buddy, you've got a hole there. As x squeezes in on 0, y is heading towards -1. Notice again, we get the limit from the y-axis. It's where the trend in y is.